Hi, everyone. I'm Chunyan. I'm a tech lead in the finance intelligence team. My talk is Applied AI in Finance Forecasting. So at Uber, we have tons of data science models across the entire company. And my team's mission is to build software to harness all these models together. And the goal is to help Uber make the best financial decisions. So let's take a look at how we do that. First, a little bit about me. I've been at Uber for almost 4 years. I started out in the growth team, and I was building a promotion and incentive platform to spend Uber's money. And then I had a change of heart, so I moved to the fraud team, to save money. Last year in this conference, I did a tech talk in the China incentive fraud problem, and that was a lot of fun. After that, I've transitioned to finance intelligence. So now my job is to tell other people how to spend Uber's money wisely. So here are some business facts about Uber. As a global company, we operate in hundreds of cities across the world. We have almost 40 billion gross booking, and that's not including Uber Eats, which is growing insanely fast. Our products serve tens of millions of users and trips every day. So to run a business of this scale, the financial planning process cannot be just a few folks tinkering in the Excel spreadsheet, which, by the way, used to be the case. But thankfully, now the process is data-driven and is powered by intelligent models. Here's the outline of my talk. First, I'm going to explain the problem space. So in addition to the need of leveraging intelligent models that I just mentioned, we also have a very special process here at Uber in terms of financial planning. These two reasons combined determines that we cannot just use out-of-the-box software provided by IBM or Oracle. We have to build our own. And then the second half, I'm going to give a high-level overview of the software solutions that we built here. And we will do a deep dive on the middle layer, which is scenario planning and optimization, specially designed to tackle the challenges in our financial planning process. So the process. Why do we need to define our own process, and specifically, why do we need to build our own software for it? The first reason is intelligence. I've already mentioned data science models. But machine intelligence is not enough. We also want to leverage human intelligence. We have amazing local team on the ground in hundreds of different cities, and they have the local knowledge that our machine learning models may or may not have incorporated. But we need to build tools to combine the power of these two types of intelligence. The second reason is agility. We need to be sensitive to market dynamics. If our competitor raise 2 billion round of new funding, we need to adjust our strategy rather quickly. We cannot afford to wait till the next year after our next financial planning cycle concludes. And the third reason is scalability. How do we scale this very complex financial planning process across 600 and more local markets to achieve both local efficiency and global optimal? These are the challenges that we face. So what exactly does financial planning entail? The first step is strategic planning. And this is, the goal is to achieve global optimal. And this is ultimately driven by CEO and CFO. They answer the question on the strategic investment level. For example, for Latin America market, it's new, it's fast growing. For next year, our strategic goal may be to double down on growth. If our goal is to increase the number of trips by 100%, how should we invest our money? How much should we invest in each market? And then the second phase is operation. The people involved in this phase is local teams in different cities. Their goal is to increase their business efficiency, and they focus on specific business metrics. A typical question they want to ask are something like, if I increase my market spending by this much, how many new drivers and new riders can we get? And then the third phase is insight. So now business is running. We need to monitor the performance and health of the business all the time. Are we on target or not? And if not, shall we adjust our target or what shall we do? And last but not least, have we learned something new from the new historical data that we collect, and how can we improve our models? We used to do this financial planning on an annual basis, and now we move to a continuous base, which we call rolling forecast. I'm gonna explain what I mean. So on an annual basis, the first step of strategic planning happens at the end of last fiscal year. The result of strategic planning is a budget allocation down to every city. And that budget is locked down for the entire year for the next fiscal year. After the strategic planning concludes, the new year starts. Each city team get their budget and get their baseline of business metrics and target they need to hit. And their goal is to hit the target within the budget. And each city kind of do it differently. They have different processes and they use different tools. Some cities have intelligent models to help them guide the decision making. But a lot of cities, they do not have that. They need to follow their guts and solely rely on the local expert knowledge. There are apparent drawbacks of this process. The strategic planning and operation are completely separated. They were run by different people, strategic planning by HQ and operation by city teams. There was no model sharing and lack of knowledge sharing in general. And more importantly, by making strategic decisions on an annual basis does not allow us to react fast if our major competitor make a main move. For that reason, now we are doing financial planning on a rolling forecast base. On a high level, the most noticeable difference is that we now do the strategic planning on a continuous basis, let's say monthly. But behind the curtain, there are a lot more changes. The models are actually now shared by strategic planning and operation, and the models are retrained and updated every month so that all aspects of our business can benefit from it. So to summarize the advantage of a rolling forecast, we now can adjust and improve our strategy on a continuous basis. We consolidate our business process and we reuse software and tools which allow us to reuse models and share knowledge across different business aspects. That was about the process. So now let's zoom in a little bit more to see what happens, exactly what we do in strategic planning and also operation. Strategic planning is done by HQ on the global level. It's budget optimization problem. They allocate budget down to every city across the world, and the goal is to achieve global optimal. Operation, on the other hand, is done by each different city, and it's a bottom-up process, and the process, we call it scenario planning. And what they typically want to do is they want to adjust different levers and see how they impact their business metrics. If I increase or decrease my market spending, how many more or less trips can I get? Those are key to the local teams to maximize their business efficiency. So let's look at them separately. Let's first look at the strategic planning. How do we do budget allocation? First, we need to decide what to optimize on, and there are a lot of things that we can optimize on. We can choose to maximize number of trips. We can choose to maximize gross booking. We can choose to minimize marketing spending, for example. And that's the objective input in this graph into the optimizer. Along with the objective, we can also pass in a list of constraints. An example of constraints can be, I don't want to spend more than $100 million in US in the month of October. Why is that? Because that's Halloween and we know that we are going to have very strong organic growth. So that statement, spend no more than $100 million in October in US, that's a constraint that we can pass into that problem. And then optimizer take this input, and the output of the optimizer is budget allocation down to every city. Each city gets its budget, and the baseline forecasted business metrics, along with spending guideline. Spending guidance is exactly how much they should spend every week. It's a time series. So budget optimization can not only run on the global level, we can actually pick any random abstraction to run optimization on. This is very valuable for us because even if, especially because we are a global business, we have different strategy, a strategic focus in different regions. United States, for example, is a relatively mature market. And next year's goal, maybe we want to hit profitability. In this case, we might want to set the optimization objective to be, let's maximize net inflow or net contribution. But Latin America is a different story. It's a new market, it's fast growing. Next year, we're going to focus on different things. We are going to focus on growth. So in this case, we might want to set the objective to be maximize the number of trips, and maybe given some constraints of spending in specific countries, Brazil, for example. So this gives us the flexibility to optimize our global business, but also stay on target and be flexible for each mega region. So the second part is bottom-up planning from each local city team. A scenario is a collection of the essential business metrics that we care about. Spending is a metric. Number of sign-up is a metric. Number of trips is a metric. Gross booking, net inflow, they are all metrics. After strategic planning, each city gets a base scenario, which is what HQ think what your metric should be. But local teams, more often than not, they know more about their specific local market than HQ. So I might disagree with if I spend this much money in acquisition, HQ tell me I can get this much sign up. I disagree because I know Taylor Swift is going to have a concert next month, but the model didn't catch that. Me as a member in the local city team, I go in into this tool, I override the metrics I disagree with, and then I create a new scenario. As a matter of fact, the city teams can create as many scenarios as they want and pick the scenario that's most relevant to the current situation. And this is how we bring the human intelligence and combine that into the overall decision making. So I've said a lot about the problem. How do we translate that and express that in an engineering problem and solve that programmatically? This is a collection of software that our team built. The top layer is an interactive UI and tooling that we built for the corporate finance people and local city teams. In the middle layer, the scenario management platform is how we calculate metrics based on and compose the model to calculate metrics. And underneath that, we have machine learning model to train those models. That includes training, backtesting, and experimentation. And of course, all good models are trained with good data. So on the lower layer, we have data pipeline and data warehouse. Let's zoom into the scenario planning platform and look at an example. As I mentioned before, a scenario is a collection of metrics. The metrics have dependencies. For example, if I change the value of acquisition spend, the number of sign-up will of course change. But exactly how it changed, that's calculated by a trained model. In this case, that's the cost curve in the middle. And all of these composition together, it's a scenario. And you may already notice that a scenario is a directed graph. Each node is a metric, and each edge is a model. The model is a calculation that takes from input metrics to output metrics. So given the initial metric, which is the entry point, entry nodes of that graph, if we run all these models in topological order, we get all the metrics that we need. So imagine after strategic planning budget allocation, the base scenario I get, I'm a city team, I get is this. HQ decide to give me $200 acquisition spend, $100 engagement spend. I run that through cost curve, and the model tells me that 200 acquisition spend is going to give me 35 new signups. But I'm city team, I know Taylor Swift is coming, so I disagree. I think 200 acquisition spend will get me not 35, but 50 signups. So I run the rest of the graph in topological order, and then I get an updated gross booking. Oh, it used to be, gross booking used to be $4,150. But now I think $4,600 is more accurate. This is how, again, this is how city teams add their human intelligence into this. And by the way, this is a super simplified example of a scenario. A real scenario kind of look like this, and this is only a part of it. The best thing about the scenario planning platform is that the shape of the scenario is not hard-coded in our system at all. We build a parser and we provide an interface to allow anyone to compose, to express their business. They can define their metrics. They can bring in their own trained models and run their financial planning needs according to their needs. In fact, we already onboard Uber Eats to do their financial planning in our next release. And it does not require any engineering involvement. So now you understand how scenario planning works. Let's go back to optimization problem. I mentioned earlier in the talk that strategic planning and operation, they are sharing models. What do I mean by that? Strategic planning, do budget allocation, it's an optimization problem. Let's say in strategic planning, we want to optimize on gross booking. Then I define my objective to be maximize gross booking. The algorithm of optimization will take that problem and translate that into a list of model configurations. And then we take that configuration and literally create thousands and more scenarios and run all of them. If our goal is to maximize gross booking, we can simply examine the output of those scenarios and pick the one with the maximum number in gross booking. It sounds very simple, right? But actually, the brain of the system is the translation from the problem to the list of configurations. That's dictated by the optimization algorithm. We now use convex optimization algorithm and also gradient descent. And our data science are in the process of developing more advanced models, algorithm to solve that. That's how we scale our process into hundreds of different markets across the world, and that's how we scale this process across time and geo. We have several next steps that we need to do in our team. This scenario planning and optimization system is actually very generic. It can be applied to any resource allocation kind of problem. We now support finance planning purpose for corporate finance and for the ride-sharing business and for Uber Eats. We are onboarding the marketing allocation optimization problem as well. And we are looking into other space like human resource optimization, hardware allocation. So we have a lot to do. And that concludes my talk.